Okay, welcome to Swell Academy. Today we're looking at radians as it pertains to degrees, angle degrees, circles, pi. And what we want to attempt to do is look at this 3, 4 different ways and see if one of those ways connects with you. I think the best way to look at this is to take a look at a unit circle. Now, a unit circle is this idea we have a radius in which is 1 unit, and that allows us to kind of uh, unveil or uncover some of the little nuances, some of the beauties of a circle. So if we just go ahead and look at a circle that has a radius of 1, and we came up with a circumference 2 pi r, well, we would come up with this idea that our circumference is, if our radius is 1, is 2 pi, meaning that our measurement of this trip around the circle is 2 pi. Now, if we were to do that, well, we would have traveled or rotation around a certain center point about 360 degrees. So the idea here is that a radian, in this case, a radian is a measure of this arc length created by a certain angle with a circle. Now, in the circle, we created a angle of 360 degrees, so that makes sense. An angle with 360 degrees that has a radius of 1, we could say has 2 pi radians. And we could continue on and say, well, if 360 degrees around is 2 pi, then I bet you if I only went 180 degrees, well, this would have a measure of pi radians, half of what, and then same thing if we went, let's say, let's go green here, 90 degrees, I would have an angle or measure of radians. I could calculate that my radians, which is related to this arc length here, is about pi over 2 radians. And you get to this idea that, okay, 1 radian, if 1 radian, in this case, if we look at it, of 360 degrees, I have 360 degrees, this 360 degree angle we created, that has a radian of 2 pi, right? 360 divided by 2. So basically, 360 divided by 2 is 180. So that's technically 180 degrees over pi, which is in fact 1 radian, which we have here, a pi radian or 1 radian. We could come to this conclusion that this angle measure, if I did 360 divided by 2 pi, or 180 divided by pi, that I could come to an estimate that the measure of 1 radian in degrees is about 57.3. And again, what we want to do, and what I want to do on this basically next slide here, is let's look at that. So if you're going to convert degrees to angles, or to radians, I'm sorry, then we are going to use this angle measure that's given to us, and we're going to multiply it by pi over 180. Because I do have for each, and we talked about in this previous slide, that in a unit circle, 1 radian, in this case, could be equal to pi over 180. They are related. That is basically 1 there. So let's just look at a radian degree measure. So we kind of came to this conclusion that a a radian is about 57.3 degrees. So if I multiply that by pi over 180, and I did 57.3 times pi over 180, I would technically get 180 pi over 180. And again, we're looking at this idea that we have this 180 degrees, we have this radian 57.3. So these things are starting to connect and be related in a sense. So again, we want to look at this in a few different ways, right? So let's pull up a circle. Let's pull up a circle here. And let's just look at a different circle. So let's look at a circle, let's say with a radius of 3. Okay. Now the idea here is if I have a radius of 4, then, or 3 in this case, then if I want to complete 1 radian, I would travel, let's say this is 3 miles. All right, let's give just, I would have to travel about 3 miles in order to create an angle of 57.3 degrees, because in this case, my radius is equal to my, let's say, arc length of 3 miles, and in turn giving me an angle measure of a radian. And you have this idea that, well, that means that my arc length is equal to what we call theta, your angle, and what we'll call r for radius. But basically an arc length equal to an angle times its radius. This is what we're looking at. And in this case, we have a radian of 1, and a radian of 1 is 3, and that is equal to an arc length of 3. My arc length is 3, my angle is a radian, and my radius is 3. So this is what we have for 1 radian. Now if we say, okay, well, what if I had an angle of 2 radians? Well, if I have an angle of 2 radians and I have a radius of 3 miles, well then this arc length here, this distance covered by an angle of 2 radians should be 6 miles. So what we're trying to do is just look at this in a few different ways so we can basically uncover this relationship of radians and degrees. And I think the last thing that's important to look at, we converted, in order to get radians, we converted degrees by multiplying by 180. I'm sorry, we took pi over 180. I'm already getting to the inverse. So if we want to do the inverse and take radians and find degrees, well then you're multiplying both sides by 180 over pi. And then in order to find degrees, well, we would just take the amount of radians, let's say 2 radians in this case, and multiply by 180 over pi, and 360 over pi, and then we would come up with some amount of degrees here. I had to go grab the calc real quick because I just making this video kind of unveiled something. So let's say this is about 114.6. So you have this idea that, and we could actually come to a radius here, that if we had a circle with 2 radians, which we know to be about 57.3, then we know we have 2 of those So again, we're looking at this idea that this amount traveled, this was 10, this amount traveled with 2 radians should be about 20. And then just again, we're looking at this relationship between radius and arc length and angle measure, and how we're basically coming to this idea that a unit circle, if you have a radius of 1 and you're traveling halfway through, you have this radian, or 180 degrees is about a radian. That's why you kind of have this one-to-one conversion that we could use, meaning that this distance here, circumference-wise, if we were to travel from here to here, we would be about a unit of 1. So you're starting to see how these things are tying together. Uh, I think the best thing to do too is to draw these circles, look at the degrees, find. You'll start to see too, just going on a tangent. You have this pi over 2, but when you start to look at the unit circle, you have this pi over 6 for your 30 degrees and your 60 degrees being pi over 3, and then you have your 45 here. That's a quarter of a radian. So you could see how this starts to lead into how we build this unit circle, or how the unit circle is used to look at radians. Um, and again, we just want to continue to make connections. And I think a lot of this too will fall into play when you start practicing radian type problems and you start to build and make the connections. So again, hard work beats failure every time. The more you fail, the more you succeed. Good to see you.